Hello, this is Anthony, and welcome back to another Python 3 episode. Today I'm going to be talking about backports. First, I'll define a backport, next I'll show how to use it in code, and lastly I'll show you how to correctly manage dependencies with backports. So first, what is a backport? The Python standard library unsurprisingly adds new features with new versions. These features may come in the form of new functions, behaviors, or even new modules. A backport packages these up into an installable Python package such that older versions can take advantage of these new features. This is particularly useful to Python 3 porting, as you'll be able to use some of the new modules as you upgrade, or you'll have access to these newer things in libraries that need to support both Python 2 and Python 3. The first type of backport I'll discuss is by far the easiest to use. This type of backport comes about when an entirely new module is introduced in the standard library, and a backport can use the same name without colliding with an existing module. Some examples of these types of backports are config parser, because the casing in Python 2 is different, enum34, which provides the enum module, and argparse, which was backported for Python 2.6. These are super easy to use because you can just use the new name in the old version, as long as you have the backport installed. Here's an example which uses config parser. The rest of the types of backports I'll discuss involve conditional imports. There's several reasons why a backport may choose to use a different name than the actual module. The first reason is if the backport is only backporting a single function. Here I'm demonstrating the usage of the backported getTerminalSize function, which was introduced in Python 3.3. You'll notice that I used the same conditional pattern introduced in episode 2 to conditionally import the function. The nice thing about this is when you eventually drop Python 2 support, you can simply remove the conditional and the Python 2 branch. The last type of backport is backporting a renamed module. This is often necessary because the same module already exists in the older version, but the new version contains some new functionality. Some examples of this type of backport are contextlib2, functools32, and mock. When using these, you can formulate your imports either to import the entire module, as seen in the first example, or to import the specific backported functionality you care about. Again, when you drop Python 2 support, you can remove the conditional and the Python 2 branch. Now that I've shown you how to use these in code, let's discuss how to declare our dependencies. It's usually undesirable to install packages you're not using, as they will add to your installation time and increase your disk usage for no benefit. As such, many of the backported modules forbid their installation when the standard library already provides the functionality. Therefore, it's necessary to conditionally depend on these libraries. The naive approach, and the only approach that was available for the longest time, was to abuse the fact that setup.py is arbitrary Python and use code to conditionally select the dependencies. This mostly works when you're installing from source, but it can cause issues when installing from pre-built wheels. If you don't know what a wheel is, it's a pre-built installation of a package. Wheels are essentially created by running setup.py and then zipping the resulted install state. Installation of a wheel is just unzip, and you're done. Let's see what happens when we build a wheel of the example setup.py and try to install it. So in this slightly contrived but realistic situation, we're building a wheel using a Python 2 interpreter. Next, we try and install the wheel with a Python 3 interpreter. It crashes while installing functools32, which we didn't want to install in Python 3 at all. The reason this happens is the setuptools metadata is written only once, at build time. This package was built using a Python 2 interpreter, so our branching code from before selected a hard-coded dependency on functools32. You can imagine a similar situation where you use a Python 3 interpreter to build a wheel, and you end up with a wheel that doesn't depend on functools32 at all, and would cause problems in Python 2. The solution to this is to use a relatively new feature called environment markers. Environment markers are a small meta language for specifying conditional dependencies. They allow you to select packages based on a number of different things, such as operating system, Python version, and implementation. The syntax used here is written so Wheel can understand the conditional dependency. Note that in modern versions of pip, you can use more operators than just equality, such as less than, to define conditional dependencies. PEP 508 includes a full list of all supported markers. This technique is also useful not just for backports, but anytime you need a conditional dependency, such as specifying a PyPy-specific library. And when we run the same procedure as before, everything works. You'll notice that functools32 only got installed in Python 2, and not in Python 3. Success! Thanks for watching. Have a good one.